Hello, and I'm Cynthia Figge, CEO and co-founder of CSRHub, the largest environment, social, and governance corporate ratings platform in the world. I'm also a FiRe advisor and previous FiRe starter. So welcome to the first session after lunch. Our panelists have deep experience in clean energy and new venture development, and we'll be discussing supporting the carbon trifecta and building Elon Musk's world. The carbon trifecta, conceived by Mark Anderson, has noted 3 enabling technologies that are approaching economic feasibility. First, carbon capture, especially via direct air capture to remove atmospheric CO2 for utilization. Second, processing CO2 into useful carbon-based materials such as graphene, carbon fiber, polymers, and nanotubes. And third, additive and advanced manufacturing processes, such as 3D printing. In building Elon's world, we honor Elon's vision for the complete transformation of energy supplies into renewables, mostly fed through electricity and supported by the decentralization of the grid. In a recent article published by Wired magazine, Mark Anderson was quoted saying, "I'm skeptical because you can't abolish the installed base by waving your hands at it. But I can imagine a future society where every industrial item is made from pollution entirely through the motives of deep spiritual regret." I'd like to briefly introduce our panelists who embody determined optimism and maybe have a little spiritual regret as well. First, Will Perego is CEO and founder of 24 Hour Solar Roof. He's a serial entrepreneur. Will has started 17 companies in the past 33 years. His incubator of clean tech startups, Green Tech Endeavors, is focused on 24-hour solar and flash charge batteries. Born in Argentina, I hear that Will is looking for a chess game.
Always.
Mark Godsy is CEO and chairman of Exro. Mark has started or co-founded many companies in the tech sector, including ID Biomedical, which became Canada's largest vaccine company and the 5th largest in the world, and the Angiotech Pharmaceuticals, which created the first coated stent and has gone on to save tens of millions of lives. In addition to working with Exro, Mark is co-founder and chair of Mojio, which was a previous FiRe starter, and a reliable source says that he is a corporate alchemist and an amazing Canadian skier.
Oh, jeez. Okay. No pressure there.
Yeah, no pressure.
Ray Gibbs is the CEO of Haydale PLC, an emerging technology company based in the UK that is facilitating the application of graphics and other nanomaterials in fields such as inks, sensors, energy storage, photovoltaics, composites, paints, and coatings. Ray did a successful IPO on the AIM market in April of 2014, and he's been involved at the board level with high-tech industry for over 20 years. Ray is a competitive sailor.
Thank you very much.
So all 3 of you are pretty advanced in your careers, and you could be doing probably just about anything you wanted at this point in your life. What does your company do, and why are you doing it? Why are you doing this particular thing at this point in your life? We'll start with Will.
I'm passionate about real estate and about sustainability. So clean energy was just the logical next step. I've been involved with renewables for the last 5 years, so through these years, or at the beginning of that process, it dawned into me that we are so lucky to live in a country like the United States, but then in many others, so there's more than 1 billion people with no electricity, no access to drinking water, and so many other things that we take for granted. if there's anything that I can do to bring some of our wealth to them, that would be an incredible experience.
Fantastic. Mark?
Thank you for the introduction, and grateful to be here. Yes, I've had a very interesting and very fortunate background as a lawyer and also as an entrepreneur, having co-founded a company that's literally saved 200 or 300 million people in the world. And it's not just those people, it's their families, it's their loved ones. And I've been, very concerned, generally about healthcare. Now my big concern is, like everyone here, I think, is the healthcare of the world. And so I've always tried to live a purposeful life, and I'm a helper by nature. And I've had the great fortune to meet our founder and inventor, and now it provides me with an opportunity to try and apply my skills in terms of building a team and move our technology and company forward.
Thank you. Ray?
I've been involved in technology for more than 20 years now, Cynthia. Thank you for that. And this is the most exciting time I've ever had, really. I want to make a difference. This is all about smart materials, making things go faster, stronger, better, lighter weighting, and making a real difference. And Haydale's right at the beginnings of that forefront of what I consider to be the next industrial revolution for me. And I do believe that, because we can make things that are 20% lighter for composite materials. Think of the weight saving that can be done. We can take a wing from an Airbus Elon and we make it 600% more electrically conductive, which will take 3 tons of copper out of a composite aircraft. Think of the weight saving, and not only that, but the performance improvement and the reduction in all the kerosene that goes out of that. So for me, it's really making a difference in the world today, and Haydale's right at the beginnings of all that.
Excellent. So in our first slide, actually our only slide.
So it's our first slide.
Our first and only slide.
Current slide.
In our current slide, despite all our efforts to date, we are not yet on a path to avert climate disaster. And time is running short. And I just made a prediction at lunch that everything that we were talking about is happening at the end of this century, and now we talk about it at mid-century. I think within a few years we'll be talking about it somewhere between 2030 and 2040. Today, CO2 levels are 410 parts per million, far beyond the 280 parts per million average for the last 10,000 years prior to the Industrial Revolution, and higher than 350 that many scientists believe is necessary to stabilize the global climate. Each year, we are putting 36 million tons of carbon dioxide in, and additionally, and even pledges made by countries that are party to the Paris Climate Accord fall far short of what is needed to halt greenhouse gas emissions. Recent political developments demonstrate that we must consider even those commitments as tenuous. So my question for the panel is, if we consider this daunting challenge and time is moving faster, how are your companies solving the carbon trifecta or Elon's dream, and how do we scale from, and since our themes are scaling and systems thinking, how do we scale from this current 1% solar or 10% renewable energy to really address this crisis?
Solar is growing exponentially. And we, as Mark says, we are accustomed to linear scenarios. What happens with exponential growth is that once you are at 1% market penetration, it only takes you 7 more doublings to get to 100%. I can see how in 1 to 2 decades we can be at 50 to 100% solar, probably 100% solar, and how also. What happens with solar also is that with each doubling of installed capacity, prices go down 20%. As of today, solar in more than 20 countries is the cheapest energy source in several states here in the US as well. But then there's still another 70 to 80% drop in prices coming. And what that means is that the more people install solar, those people withdraw from the electric grid, but then the electric grid needs to charge the remaining people more because the nuclear plant and the coal plant cost the same to run. So the more people jumping into solar, the more the prices from the utility companies go up, which accelerates the rate of more people dropping because their prices are going up and the neighbor enjoys solar. I'm very happy. It's a very dark photo, but I'm very optimistic about the movie.
Mark.
Thank you. What we do is we have the ability to convert nature's variable energy into electricity. And I'm not a technical person per se, but it was just mind-boggling to me when I learned about Exro that we weren't able to do that. We can put a person on the moon. There's a lot of things we can do, but we can't do that. And a story that comes to mind, just a few months ago, I was in the Bahamas and I happened to meet the fellow who is the manager of the power system for the largest island. I met him on the beach just by happen chance, and he said he was an electrical engineer, told me what he did, and I said, well, do you have a couple of minutes for a story? And he said, yes, of course. And so I shared with him the Exro story, and his eyes started to well up, and he looked out at the ocean, and he said, ever since I was a little boy, I dreamed about these waves being able to power our island. What we have is we have an intelligent technology that makes a generator intelligent so that it can convert variable energy in an efficient way into electricity. And in keeping with Elon's thesis, when you produce, if you're going to have an electric car, but you're going to power that car based upon electricity that's been generated at a coal burning or gas burning facility, it somewhat defeats the purpose. And so it's very important in terms of just the production of electricity. Just a few hundred miles of the eastern seaboard would be, if you had wave systems, would be enough to power all of North America. And so, our goal is to offer our technology to companies and integrate it so that gentlemen on the beach and people like myself, you mentioned about skiing. I grew up in a small town in central British Columbia. And we're known for all the helicopter skiing and one of the best ski areas in North America. But what people don't know is there were 3 lovely little family ski areas just next to our town, and they're all closed. And they'd be lucky to be open for 2 or 3 weeks in the entire season. Right. So what we hope to do is to be able to offer now a solution that will be more harmonic with the planet, and then in terms of consequence with these graphs, make a material difference. That's our hope.
Thank you.
Thank you.
Ray.
Talking of material difference, we deal with advanced materials, which is all about making, brilliant segue, thank you very much, which is all about making things smarter, making things more electrically conductive, making my boat go quicker would be good, wouldn't it? And if you think about composite materials in the world today, the composite materials is a $100 billion market, and it uses an awful lot of weight. If you can take 15 to 20% of the weight of composite materials out and replace it with just a little bit of nanomaterials, 1/2 to make that change, the weight saving, let alone anything else, in the reduction in the power to take and to do stuff, would make a massive difference. The car industry generates 1/6 of all the GDP in the world today, and it uses an awful lot of energy.
Yeah.
Let's get to grips with that. Let's get to grips with the mechanicals of that, making things smarter, using boron nitride, which is known as a white graphite, as a methodology for doing heat exchange systems, because heat is one of the biggest single issues. You heard all about it yesterday. Heat is one of the biggest single issues in our world today. graphene is brilliant at doing heat dissipation.
So there, I think, is a natural tension between our goals as a world to have health and save the planet, and your businesses to prosper and be successful. And as fire starters, you can tease us a little bit right now if you have something right on the horizon that you're about to launch or offer, or any partnerships, and tantalize us with your business model and where you are.
So with the 24-hour solar roof, we should have a fully functioning demo unit before year's end. And the goal is that from the roof, any of us can have all the electricity and all the water that we need 24/7. Next year, we should have the first product in the market for another company, flash charge batteries, which is a fast charging battery. So it should recharge, as an example, your cell phone in 3 minutes rather than 2 hours. Last 100,000 charge-discharge cycles instead of 1,000. Non-flammable, non-toxic, etc. And a third company, which we haven't named yet, hopefully for next year as well, is to allow for neighbors to trade their renewable electricity among themselves rather than through the utility company, in cases like in Miami, where if I have solar panels and I sell my solar energy to my utility company at 3 p.m., they pay me wholesale, and a few hours later, when the sun is down and I buy electricity from them, they sell my electricity back to me at retail prices 400% more than what they paid me.
Right.
So hopefully by allowing neighbors to trade among themselves, we stop some of the cheaters.
Yeah. Mark.
Well, our technology is so pervasive. It's really like, how do you boil an ocean? Our business plan is a combination of chess and dominoes, and we're in the chess stage right now. We've created 3 prototypes internally, and now we're commercializing our technology in 4 different areas. The first area is on the generator side, and we're working with the world's leading supplier of propulsion systems for drones to validate our technology. We're also working with a company in the motor side that I'm not at liberty to speak about, but a household name. Internally, we're building a reversible machine for a bicycle, and what it will do is it'll make the bicycle much more efficient on the acceleration, and then on the deacceleration, we'll be able to capture all of the energy to regenerate that, or to convert that into electricity. And then we have a wind initiative. By virtue of creating these collaborations, our expectation then is to then move into dominoes, and to, with that, invite parties to work with us and build from there. It's a daunting task. When we started Angiotech with the coated stent, I had no idea that we would be able to scale that to virtually about 300 million people in the world. I think in this case, if you look at 7 billion people on the planet, and the number of electric motors or generators that touch each individual, I'm not sure what the number would be, but it would be a multiple of that. And I think in the next 5 years, if we have, if we play this chess and dominoes right, and really it's a relationship-oriented type business because the economics are there, I'd like to see our technology in at least 500 million machines, covering cars to fans to generators to wind settings. And we've got a great team that's very committed to do that. But obviously, it's now all about execution. Meetings or conferences like this are an opportunity to work with people. As Katia said earlier, it takes a village to make this happen. We've got to find the right synergies and the right alignment. But that's our goal.
Great.
Thank you.
Ray, how about?
Okay, there's a couple of things I want to say. One is that one of the unseen polluters in the industry and industrial world today is the oil and gas industry. Not the pollutions for the diesel or the fuel that we use and burn, but all the pipes that are out there that the oil and gas guys do not know where they are, and they leak badly. The repair bill for a Saudi Arabian company that I can't name is over $1 billion a year. And they are still trying to fix holes. We have a technology using advanced materials, a repair patch, that can permanently bind that. It's impermeable to gas, it's impermeable to chemicals, it's made with silicon carbide. It would solve so many of those issues today. That's one. Besides which, we've got the ability to put a thermoplastic reinforced pipe that becomes a replacement for steel. It's also recyclable. Tick the box. There's another company, we're dealing with things in the thousands of tons. Big, big stuff. We're not in that game. We have a supply chain that does it. There's a company called Advanced Metallurgy Group. It's a NASDAQ-quoted company. It's run by a 72-year-old autocrat called Heinz Schimmelbusch. I won't go to that too much with you, but he's brilliant at what he does. He measures everything by CO2. Everything. Why do we not all measure our corporations with CO2? It would show so much about whether we're good or bad. It's a very, very important point. And he owns a business in his sector called AMG Mining, and they mine graphite around the world. 750,000 tons of graphite are mined in China every year. And the yield of that is around about 3 to 4%. So for 750 million tons of it, you've got 3 or 4% of graphite, and the rest of it is spoil. So he's looking at that, and they are ready to scale up on all the things we do. We give them the technology to add the nanomaterials, to put it into a polymer, a resin, whatever system it is, and they are ready to go. And that's what we need to do. We need to put the supply chain in place. The graphene space, we've checked around about 230 different materials of graphene all around the world. Every single one is different. Every single one is different from its flake size, from its appearance, from the chemical groups on the surface, or the thickness of the material which you're dealing with, because everyone mixes and matches what graphene's all about. That needs to be resolved. Standardization needs to be done. Otherwise, you're never going to have a level playing field for everyone.
So I'll ask one more question and then be thinking about any questions that you might have. But about 1 billion people do not have access to electricity, and roughly 700 million people do not have clean water. What are the financial models for rest of world and developing world?
For these last years, what it has been observed is that the model that probably makes more sense is the pay-as-you-go model, where using the solar roof, 24-hour solar roof as an example, if we would build, so there's these remote villages with perhaps 500 families with no electricity, no water. So if we would build a community center for them with the 24-hour solar roof, now the entire village would have electricity and water.
Yeah.
And so these families every day get to neighboring villages that have electricity, and they may need to travel 5 miles per day, sometimes walking, just to go and pay 25 cents to recharge the cell phone and come back, and or to buy bottled water. So if now they have it in the village, the same money that they were paying, but that it was so time-consuming for them, they would have it right on their village, and also this community center can be used for the entire community to now the children have light to continue to study at night, for the mothers if they want to do work like sewing or other types of work that then they can sell and things like that.
Yeah, thank you. Are there any questions in the audience?
Can I add to that?
Yeah, please.
Yeah, absolutely. There are going to be enormous tensions in the developing world around energy. You know, just the thought of creating air conditioners in Africa, which is going to happen, is just such an enormous, enormous issue. And as you were describing, you know, just the electricity needs. And so, and that also creates a whole bunch of political tension. There's sort of landlord energy providers, and there's sort of tenant energy users. And the vulnerability that we see and the tension that's created amongst countries, you know, we believe that, you know, there's abundant energy, as I described sort of the amount of energy in waves or in tidal. In the Philippines, there's an area that could basically power the entire country just with tidal forces. But right now, because of the variability, it's not possible. So, you know, we hope to be, you know, an important player in all of that, so as to ensure that people enjoy a good quality of life, they have access to things, and why shouldn't they have air conditioning? However, if it has a big impact on the environment, of course, then it comes with a major consequence. So, so absolutely, those trends are going to add to those potential lines there, and we hope to be able to meet that. Thank you.
Thanks.
You've moved us off of CO2, but I want to just pick you up on one thing, that's water. It's criminal, isn't it, that in the developed world today, people don't have access to clean water. Now, you can use advanced materials, graphene in particular. Graphene oxide will filter water to give you clean drink. And we've actually working with Sellafield, which is the nuclear program company or group up in north of England, to actually use graphene or graphene oxide to clean the wastewater that comes out of the nuclear industry, and it's pretty horrific if you think about it. And that's one program of what they're using graphene as a methodology for cleaning water up. And it's accessible. You can use graphene now, put it into a bottle, create a filter, pour contaminated water in, and it will clean it up. The military use it a lot, and they have to, because they never know when they're going to use dirty water to drink.
Wow. Well, thank you. I want to thank our panelists for being visionary and leaders. And I want to quote Mark as we close that while the map is important, the compass is critical.
May I add another quote? The road to success is always under construction.
Yeah.
Thank you very
With
much.
smart materials.
Yeah. Okay. Thank you. Thank you. Thank you.